All right, we're going to jump into lesson 2.4, which is going to be creating and solving inequalities. And we'll start with a couple of vocab words here. The first one is equation, and this just is a statement that includes an equal sign. And that part is important because it has the equal sign there, and you've seen plenty of these before. So something like x equals 2 would count as an equation because it has the equal sign there. And if I wanted to graph that, it would just be one single dot here on the number 2. Okay. And now we'll move to an inequality, and this inequality is going to include an inequality symbol. So you may have seen these before, but they'll look something like this. This is one option, x is greater than 2. And now we're looking for any numbers that are greater than 2, and those would be considered solutions. So that could be like 2.1, right, or 3, or 4, or 100, or 500, right, anything bigger than 2. So now we have a group of solutions, and we'll talk about how to graph this in a second, but we know it's going to be anything that's over there on the number line, all the big numbers. Hey, and the important distinction here between equation and inequality is that equation usually has one solution. Most of the ones that you see have one solution, whereas an inequality has a group of solutions, right? 3, 4, 5, all those would be solutions to this one that we just talked about. So we have 4 options for inequality symbols. We have a less than symbol, which looks like this, in that direction. Right? Sometimes I do this so that we can see it's less than. See that L there? Okay. We then have less than or equal to, which would look like this. We have greater than, which is in the opposite direction. And we also have greater than or equal to. So the or equal to has the bar underneath, right? Like it's half of an equal sign. Okay. And now let's talk about the symbols that we use on the graph. So if it's a less than symbol, right? So if it's less than, that's going to be an open circle on my number line. So let's say we had it less than 0, right? It would be an open circle at 0. Whereas a less than or equal to would be a closed circle. So that's the distinction there. If it has the or equal to bar, it's going to be a closed circle. And if it doesn't have it, it's going to be an open circle. All right, let's look at a couple here. So the first one here says x is greater than 2. This is one we just did. Notice it's a greater than symbol. Okay, so that's going to be an open circle at 2. And we want numbers that are greater than 2. That would be like 3, 4, and 5. So that's everything to the right there. So my graph will look like that. Sliding to letter B here. Now x is less than or equal to -1. So notice this time we have the or equal to bar there. So we know it's going to be a closed circle. It's going to be at -1. So I have got my closed circle there. Okay, and less than or equal to -1 is going to be to the left because we want the numbers that are less than that. So -2, -3, and so on and so on. We'll keep moving here. We've got x is greater than or equal to -3. So again, it's got the or equal to bar, so it's going to be a closed circle at -3. And we want numbers that are greater than that. So that would be all the positive numbers. So I want to point towards the positive numbers here. And then I'll slide over to letter D. This one kind of gives us trouble sometimes because notice the x is on the right side. Okay, so I could rewrite this as x is less than 4, and now I can read it left to right. Okay, so I just kind of flipped that thing 180 degrees. I just swiveled it around, and it's a little bit easier to read then. So we have x is less than 4, so I'm going to go to 4. It doesn't have the or equals to sign, so it's an open circle, and we want numbers that are less than that, so that's everything to the left, all the smaller numbers. Okay, we'll keep going here. Jump into 2a. This time they give me a picture of the graph, okay, and now we've got to go ahead and write what the inequality would be. So for this one, we've got x. We're going towards bigger numbers, so I'm going to say is greater than -3, and I have to decide if I want to put the or equal to bar, and this is an open circle, so I don't want that one, and I'm just going to leave it like that. Sliding to letter B, now we have x is, we're going towards smaller numbers, right, pointing to the left, so x is less than 2. And I have to decide, do I want to put the or equal to bar? And for this one I do, because we have the closed circle there. So I want to put that or equal to bar. All right, let's keep moving. We'll go ahead and solve a couple of these. Okay, so you solve them just like equations. You treat the inequality symbol just like an equal sign. So for this first one here, we're trying to get x by itself, so I would add 6 to both sides. And I get x is less than or equal to 9. Okay, and then I can put that on the graph real quick. So x is less than or equal to, so closed circle there. And less than is going to send me to the left. And we'll keep it moving to letter B. Okay, same idea, add 5 here because we're trying to isolate x. X is greater than 8.5. So I'm going to go to 8.5. We'll try to get as close as we can here. 8.5, which would be right in between 8 and 9. And greater than that is going to send me to the right, to the bigger numbers. We'll keep moving. Okay. Same idea here, get x by itself, so I'm going to subtract 7. I get 2 is greater than or equal to x, right? Or I can flip this thing all the way around. So I could rewrite this as x is less than or equal to 2. All right, so I just flipped the whole thing around, including the inequality symbol. And now I have x is less than or equal to 2, so I'm going to put a closed circle at 2, less than to the left, okay, and we end up with that graph. Keep it moving here to letter D. All right, I'm going to go ahead and subtract my 1.9 here. So we get W is less than or equal to, okay, so we need to go ahead and subtract. These are both negative numbers here, right? So I know decimal is a little bit trickier, but same idea. So hopefully we're ending up with, let's see, 4.7, negative 4.6. And so then I can go to negative 4, and 0.6 is going to be in between 4 and 5. So it's going to be right about here. And we want to go less than or equal to, so to the left of that. And we end up with a graph like that. All right. Same idea here with number 4. It's just a more complicated inequality here. So I'm going to start using some of those steps that we had talked about in a couple lessons ago, combining some like terms that are on the right here. So I get 4y plus 1 is greater than, this turns into 4y minus 8. And now we're going to go ahead and get y's together. So subtract 4y and subtract 4y. And we're going to notice here the y's are all going to cancel out. So my variables are gone, and I get here 1 is greater than negative 8. I have to decide if that's true or false, kind of like we did with our equations. Is 1 greater than negative 8? Yes, it is, right? Because 1 is positive and negative 8 is negative. So that's true, which means I have infinitely many solutions. And so what they're going to have you do on your homework is just go ahead and draw this thing to include all the numbers, right? Arrows in both directions here, okay, because it's all the solutions. And then we'll slide over to letter B. Okay, so again, I've got some like terms here, 2x and 3x. I'm going to combine those to be 5x minus 8 is greater than or equal to 5x minus 4. Get my x's together, so I'm going to subtract 5x. And again, these variables are all canceling out, and I'm left with negative 8 is greater than or equal to negative 4. So it's asking me, is negative 8 greater than or equal to negative 4? No, it's not, because it's more negative. So this is false, which we know means no solutions. And so I'm not going to put anything on the graph there. Okay. Keep going here. I'm going to jump straight down to letter E just for the sake of time. I'll do letter C, I suppose, because it's got some distribution there. Okay, so if we were going to go ahead and distribute this one, We'll distribute, that's going to give me 3b minus 3 is less than 3b plus 3. Subtract 3b. The b's are going to cancel out there again. And I get negative 3 is less than positive 3, which is true. So that's going to be many solutions, because negative 3 is less than positive 3. So then we would have our arrow going in both directions here. All right, I'm going to skip letter D. I'm going to go down to letter E. This one looks super simple, but there's one key part here that we have to remember. You might remember it from before with inequalities, and that's when we divide by this negative 3. When I divide by a negative number, right, or multiply by a negative number, when I'm dividing by a negative number, I have to flip my inequality symbol. Okay, so I'm flipping that symbol, and now we have x is less than negative 8. Okay, and that's going to be what I graph there. So when we're dividing by a negative, flip the symbol. I'm going to make a little star here. So when we divide by that negative, or really when we multiply, which is like a version of division, right, we're going to flip the symbol. So x is less than negative 8. That's going to be an open circle, and we're going to the left. For the smaller numbers, the less than numbers. And same idea on letter F here, right? We're dividing by negative 6. So when we divide by this negative number, we got to flip the symbol. So instead of pointing in that direction, we're going to flip it around. Right? 36 divided by negative 6 is negative 6. Okay? And so now we have negative 6 is less than or equal to n, or I could rewrite this as n is greater than or equal to negative 6. Those two things are the same. That's going to be a closed circle at negative 6, and greater than is to the right. All right, now we'll take a look at a couple of word problems here. They're going to have you set up these inequalities. It says all real numbers x greater than or equal to 5. So we've got all numbers x greater than or equal to 5. It says which of these are solutions. Okay, so which of these numbers are greater than or equal to 5? Well, 7 is definitely greater, and 5 is equal, so that counts as well as a solution. Let's go to letter B. This says 9 less than a number x is greater than 3. So we have this number x, but we want 9 less than that, so I'm going to subtract 9 from it. Okay, is greater than 3. Okay, so that less than a number is kind of tricky because we're writing it what it looks like backwards, right? But we have the number 9 less than that would mean I'd subtract 9 is greater than 3. Okay, go ahead and solve this by adding 9 to both sides. So I get x is greater than 12. We want all the numbers that are greater than 12. Well, that's definitely going to be 92, but does 12 count? No, because it is not greater than 12, right? It's equal to 12. So if we had the or equal to bar, then that would count, but in this case, it does not. Let's keep going to letter C. It says the sum of a number of 7 and a number is more than 5. So we have x plus 7, right? 7 and a number is more than, so I'm going to say greater than 5. And then from here I can go ahead and subtract 7, so I get x is greater than negative 2 after I subtract 7. So we want all the numbers that are greater than negative 2. Well, that's going to be positive 7, that's going to be 0, and negative 2 again does not count because we do not have the or equal to bar. And then finally, letter D here, it says 5 times a number x. So 5 times a number x is less than or equal to 25. And then we'll go ahead and solve this by dividing both sides by 5. So I get x is less than or equal to 5. And now when all the numbers less than or equal to 5, well, negative 11 will work. 2.5 is less than 5. And 5 is equal to it, so that one counts as well. 10 does not count. All right, that